We're talking about null hypotheses and alternative hypotheses. Particular compound in drinking water is not hazardous if it is present in 33 parts per million or less. An environmental watchdog group believes a particular supply of water does not meet this criteria. So what is the null hypothesis? Remember, null stands for the thing that can be nullified, not like null set. And that is that the level is less than or equal to 31. You always, 100% of the time, have the equals involved with the null hypothesis. We never put it with the alternative hypothesis. In this case, the alternative to being less than or equal to 31 is to be greater than 31. So the alternative hypothesis is that the level is greater than 31. Number 26, what does a p-value represent? Well, what are the smallest and largest possible p-values? Is a p-value of 0.000 and so on 5 possible? Yeah, that's absolutely possible because a p-value represents probability. A p-value is always between 0 and 1 in the same exact sense that probability is always between 0 and 1 and it can equal it. Okay? So is 0.000 blah, blah, blah 5 possible? You bet. Yes, it is. What about 1.5? No, absolutely not, because 1.5 is not between 0 and 1. What about negative 0.5? No, definitely not. It's not between 0 and 1. Number 27. For this problem, we're going to change to 300 students and 7.5 hours worked instead of 7.4. Standard deviation is 3. To do this, the first thing we have to do is, when we look for the confidence interval, is figure out, okay, well, if we have a confidence interval of 90, I want to find what part of the graph is not shaded and figure that out. By that, I mean the normal curve. So that'd be 1 minus 0.9, which gets me 0.1. Got to divide that by 2 for the two tails at either end of that normal curve, and that would be 0.05. Then I do second var's inverse norm, which is 0.05. And then the 0 and the 1 for mean and standard deviation is what will give you a z-score. And it gives you a z-score of negative 1.6449. And to find the error-bound measurement, we use that 1.6449, multiply it by the standard deviation divided by the sample size. In this case, divided by 300. When I crunch that all out, I get 0.712. And then I take the mean and I go up 7.2 and down up 0.712. I go down 0.712. That gives me 6.788 and up 0.712, which gives me 8.212. That establishes my confidence interval. Okay. Number 28, let's draw some conclusions based on the p-value. So suppose our p-value is 0.074. How will our conclusion be affected by alpha levels of 0.10, 0.05, and 0.01? Well, 0.074 is less than 0.10. And remember the saying, if p is low, the null must go. So the p is actually lower, 0.074 being lower than 0.10, so the null hypothesis must go. For the next one, the 0.074 is greater. So if the p is high, the null must fly. And for the last one, it's greater still. So if the p is high, the null must fly. And the last part of this particular page involves type 1 and type 2 errors. There are two things to remember. Type 1 errors occur only when the null hypothesis is true. Very important to remember that. Type 1 errors occur when the null is true. Type 2 errors occur when the null is false. Okay? And the other thing you got to remember is, look, if the conclusion's correct, it's not an error. Okay? So you can't possibly have an error if the conclusion is correct. So for example, if the parachute is safe when in fact it is safe, that can't be an error. It's safe. You're concluding it's safe when it is safe, so it's not an error. The conclusion is valid. So state the 4 possible outcomes when considering a null hypothesis that swimming with great white sharks is safe. And then also the 2 that are valid, and the 2 that are type 1 and type 2 errors. So, first possibility, you think swimming with great white sharks is safe when in fact it is safe. Second possibility, you think swimming with great white sharks is not safe when in fact it is. Type 2, third possibility, you think swimming with great white sharks is safe when in fact it is not safe. And the last one, you think swimming with great white sharks is not safe when in fact it is not safe. Now, the first one, assuming that it's true that it is safe, you think swimming with great white sharks is safe when it is safe. That's valid reasoning if they tell you, yes, it is safe. Maybe they have their jaws wired shut. And then the last one, they unwire the jaws. You think swimming with great white sharks is not safe when it is not safe. Those are both valid thinking. That's good thinking. There's nothing wrong with it. However, the two in the middle are good examples of stinking thinking. Type 1 error only occurs when the null is true. So look what's happening here. You think swimming with great white sharks is not safe when in fact it is safe. This is a type 1 error because it is clearly an error. You think it's not safe when it is safe. But in this case, the null is true. So that's why it has to be a type 1. The type 2 occurs when the null is false. That's the third one down. And that is the most dangerous one here. You think swimming with great white sharks is safe when in fact it is not safe. You will be shark chow. Okay, have a good one.